Hello all. Today we are solving LeetCode problem number 1382, balance a binary search tree. So we are given a binary search tree BST. We have to return a balanced binary search tree with all the same node values. If there is more than one answer, return any one of them. So anyway, we are given a root of the binary search tree. So we have to we have to form a binary search tree and we have to return it. So it is not all the possible binary search tree that could be formed should be returned. Any of the binary search tree is enough for this solution, sorry, this problem. So they are given also the binary search tree is balanced if the depth of two subtrees of every node never differs by more than one. So this is the condition for the binary search tree to be balanced. So we saw the same in the yesterday's problem as well. So how do we solve this? The solution is pretty straightforward, which is very simple to solve, but to come up with that particular solution is pretty hard. The way we have to think for that is little hard. So I will explain how we will be solving this with the solution. It's first thing first is we have to traverse the given route. We have to traverse in order traversal, and we have to fill in all the values in a list. So basically we have to traverse through the given route and we have to fill in all the values in the in order way, which is nothing but left, then the node, which is the root, and the right. So this is how we traverse, right? So I will explain when we are running through the first example for this problem. So the next thing is, after when you have all the values in hand, you have to use the same a similar method, which is similar to the binary search, where you will have you will fetch the elements from the mid of the array, and then you will add it as a root, and then you continue the same. So find mid, and the value of mid will be the root, and left subtree will be the left values, which is from 0 till the mid minus 1. So 0 till mid minus 1 will be the left subtree, and right subtree will be mid plus 1 till n minus 1, which is n is the length of the array formed, right? So this is how we this is the solution for this particular problem. So let me show the try run for this. So 1 2 3 4 is the given tree, so which is 1 2 3 4, sorry, this is 3 and 4. Since there is no left subtree here, since it is everything is in the right side, so this the in order traversal will be like 1 2 3 and 4. So this is how it will be. So there is, if there is left, for example, if there is some node like 0, you have to add 0 front, but here there is no 0, so this will be the values which is formed by in order traversal. And now what you will do is you will have left pointer, which is 0, and right pointer, which will be len of the values minus 1, which is nothing but 0 1 2 3. So this will be 3, right? So now we have to find the mid will be 0 plus 3 divided by 2, which is 1. So let me change the color time. 0 1 2 3. So first node will be 2, so this will be the starting node, and we have only 1 here, whereas we have 3 and 4 here. So this is the next set of subarray, or subarray, right? So now since we have only 1 here, this can be transformed to 2 and 1. We still have 3 and 4, and the index positions are 2 and 3 respectively. Sorry, this is 2 and 3 respectively, right? So the new left will be 2 and right will be 3. So 2 plus 3 divided by 2 is nothing but 2, which is mid. So from here the 2 is nothing but 3, so this will be 3, and you have 4 left. So anyway, you will repeat the same thing until there is no node left, which means there is no node left, right? So you will repeat the same operation, and because of that you will find the right subtree and left subtree. So this will be finally 2 1 3 and 4. So this is how you connect the tree, and you return this tree as the answer. So this is how you solve the problem, and the time complexity for this will be big O of n, and big O of n as space complexity, as we are traversing through each and every node for building the in-order array, and we are using n space for the in-order values, right? And again we are building the array, so which consumes the tree node as well, so which will be of big O of 2n, which can be written as big O of n. So with all these observations, let us go ahead and code this up. So the first thing we start with is we have to declare a in-order traversal function, which we will traverse through the tree in in-order way, and we append the values based on the in-order way, right? So which we will be using to create the new balanced tree, in fact, right? So first DFS, we need for this, we need a we need a list to store all the values in order way. So node, and let the list be val. So if not node, return none, right? So now we have to traverse the recursive call for left, and then we will be appending the values, whichever values in the node, right? And then we will move right. So based on that, DFS node dot left, and you'll have the val again. Now you have to append, so val dot append node dot val, right? So now the DFS right call, so DFS, this should be node dot right and val. So since we are having the node dot val for the values, I think it's better to name this as vals, or this might create confusion. So right, yeah, so now it's good, and this function takes care of filling in all the vals with values in order way. So now we have to define the next function, which will build the binary search tree, right? So for this, again, you need the vals, the same the array, and followed by left and right. So since it is we are building it by using the mid value as a root, and we are building the left of the mid value to be the left subtree, and right of the mid value be the right subtree. Since we are following that pattern, we have to you use these two pointers left and right. So first condition here, the base condition would be if left is greater than right, then you return none. And now you have to find mid. Mid is equal to left plus right and should be divided by 2. So now with that, create a node. Node is equal to tree node, where you pass in the vals of mid, right? So now you have to build the tree. So node dot left is equal to this should be build, and it should be vals, then followed by left, and then the right strings to mid minus 1. And similarly node dot right will be equal to build, where vals, then followed by this should be mid plus 1 and right. So now that we have built the tree, and now we will be returning the node, since the node will be the root of the tree. So that is it for defining the function. So now we have to call it. So vals is equal to, we are declaring creating a list to store the values, and now we have to call the DFS, passing in a root and vals, which will fetch the values in in-order form, append the values in in-order way. So and now we return build, where we pass in the vals, and we start from 0, and right will be length of vals minus 1. So it's good to go, and let us submit this. There we go. Let us submit this, and this is a pretty efficient solution. Thank you.